So this is the 10th session on rigid body kinematics. So in this also I'll take up problems on SRC procedure for velocity. In case you don't know the theory of the numerical of this video, you must go to the 7th and 8th video. Then only you must come to this one. 7th, 8th and 9th you must see. Then you must come to 10th. Okay. 9th video also I discussed numerical problems on rigid body kinematics for SRC procedure for velocity. So in case you are new to this, you don't know this theory beforehand, you will first see the 7th and 8th video. You will see the questions on this chapter in 9th video, and then 10th you come to this, okay. So I'll take up some more problems, okay, fine. This is the question I'll take up is this. Question which I'm going to take up is this. A rigid rod P1, P2 of length L, a rigid rod P1, P2 of length L slides down a fixed vertical wall as shown. Slides down a fixed vertical wall as shown. This is the vertical plane, vertical wall. This is the horizontal ground. This is the horizontal ground. This is right angle. This is the rod, length L. Upper end is P1, lower end is P2. Okay. At the instant of the question, this angle is theta. Angle theta is given. Okay. Angular, the rod is, you can see, P1 is going downward. Rod is rigid, the P2 should go that side. So rod is definitely rotating in a clockwise, anti-clockwise sense. At this given instant, angular speed of rod is omega, anti-clockwise. This is the angular speed of rod at the given instant, omega, anti-clockwise omega, with respect to ground. Omega we know will be equal to d theta by dt. Okay, fine. Now we are given at the given instant velocity of P1 is v1 with respect to ground speed, and speed of P2 is v2 with respect to ground. Okay, omega is also with respect to ground at the given instant. Okay, v1 is the speed of P1 with respect to ground, v2 is the speed of P2 with respect to ground. Omega is equal to d theta by dt. Sense of rotation is anti-clockwise. Okay. Now question is find v1 by v2 by several different methods. By several different methods, we have to find v1 by v2. Fine. We have to find v1 by v2 by several different methods. So method 1, M1 meaning method 1. See, method 1 is by method of coordinates. Okay. In method of coordinate, if you don't know any concept about SRC procedure also, you can solve it by method 1, by method of coordinates. I'll write here, by method of coordinates. So in method of coordinate, what we do, we set up a convenient coordinate system. Suppose we take this to be the origin, rightward horizontal to the x-axis, upward vertical to the y-axis. This is the rod, okay. This is P1, this is P2, this is theta angle, this is length L. Now P1 moves along y-axis. Its coordinate at an instant will be 0, comma, this distance will be y coordinate, that is just L cos theta, right angle from trigonometry, L cos theta. P2 moves along positive x-axis. Its coordinate will be this distance, L sin theta. L sin theta, comma 0. Alright. Now P1 has a speed of v1 in downward direction. P2 has a speed of v2 in downward direction, in rightward direction. Fine. Alright. Now we have to find v1 by v2 by several different methods. Okay. So now see. Point P2 moves along positive x-axis. Its x coordinate is L sin theta. So V2 is by d by dt of L sine theta. Okay, dx by dt, point moving along x-axis, its velocity is dx by dt. X is the x coordinate of point, x coordinate of P2 at time t is L sine theta. So d by dt of this V2. Now L is constant, L comes outside. D by dt of what? Sine theta. Fine. This era bit. Now V2 will be L d by dt of sine theta. So this becomes L times d by d theta of sine theta into d theta by dt. D by d theta of sine theta becomes cos theta. D theta by dt is omega. So V2 is equal to omega L into cos theta. Okay. Now consider P1. Y coordinate of P1 is L cos theta. P1 is moving along negative y direction. Its speed is V1. Its y coordinate is L cos theta at time t, that is decreasing. So V1 is mod of d by dt of y2, y1, where y1 is what? Y coordinate of P1. That is simply L cos theta. Now you can see in this problem, as time passes by implies y decreases with time. So in that case, speed is the we know that speed is the magnitude of velocity, magnitude of dy by dt. But y decreases with time. So y decreases meaning dy by dt is negative. This is negative meaning speed is just equal to minus of dy by dt. Is it clear? Sorry, y1, not y1. Minus dy1 by dt, that is speed. Speed is minus of dy1 by dt. Now y1 is how much? L cos theta. This I'll grab it, okay? So speed becomes V1 is equal to minus of d by dt of L cos theta minus L d by dt of cos theta. So this becomes minus L chain rule d by d theta of cos theta into d theta by dt. Now d by d theta of cos theta is minus sin theta. Minus plus becomes plus. D theta by dt becomes omega. This becomes omega L sin theta. Okay, fine. So this becomes, so V1 becomes this, V2 becomes this. So V1 is equal to how much? Omega L sin theta. V2 is equal to how much? Omega L cos theta. We have to find V1 by V2. So V1 by V2 becomes omega L sin by cos. Omega L sin theta by omega L cos theta. Omega L cancels out, sin by cos becomes tan. So V1 by V2 becomes tan theta. This is the required answer by method 1. This is the required answer by what? Method 1. Okay, fine. So V1 by V2 becomes tan theta. That is the answer by part first method. Okay, fine. Now we solve it by method 2. Method 2. Okay. Now method 2 by method of SRC for velocity. SRC procedure for velocity. By SRC procedure for what? Velocity. I'll learn the first column, okay? So in SRC procedure of velocity, we have two sub cases, case A, case B, in which we apply SRC between P1 and P2. And we take P1 to be the SP. And second is SRC between P1 and P2 and taking P2 to be the SP. So by two different sub cases we will solve method 2. Okay, fine. Alright, so we take method 2 part A. We take P1 to be the SP. As I discussed in the 8th video, that while applying SRC procedure for velocity, at least velocity of SP or OP should, one of the points should be known. So it is not necessary that only we can take that point to be SP whose velocity is known. We can take other point whose velocity is unknown, that also we can take to be SP. But then next point, other point should be, velocity should be known. So in this now, see, this is part A, alright, fine. In part A it is like this. This is P1, this is P2. Now in this, as I wrote here, SP is P1, OP is P2, okay. So this angle is theta, okay. So we draw the line joining SP and OP, whose orientation is same as in the problem. So this is the P1, this is P2. This is theta angle, alright. Now, what do we do first? We give the velocity of SP to OP. Velocity of P1 is what? V1, downward direction. So we give velocity of V1 to P2. Okay. Now, since omega is what? Anti-clockwise. Now we write down the sentence. OP, that is P2, moves in anti-clockwise circle, whose center is at SP, that is P1, and radius is L. Now if this is to be the center, this is to move in anti-clockwise circle, P2 should move in this direction. Omega L rightward, right angles. Okay, this is the second action. The velocity of P2 should be vector sum of these two. Okay, velocity of P2 is the vector sum of these two terms. Okay, now see one thing. This is right angle, this is theta. This is 90 degree minus theta. This is 90, so this becomes theta by geometry. Now this I'll have it, okay. So velocity of P2 is the vector sum of these two terms. Okay. And we also know velocity of P2 is how much? V2 in rightward direction. So resultant of these two should be in rightward direction. Okay. So now at this stage, we can again solve this problem by two different subcases. One thing is this. See, velocity of P2 is how much? V2 in rightward direction. Is it alright? So V2 is the vector sum of these two terms. So resultant of these two terms is in this direction. Now here we can either use the parallelogram law of vector addition, or we can use the component form. That also we can do. We can take either of these two steps. Suppose I use the component form. So resultant of these two vectors is in this direction. So vertical component of these two vectors should cancel each other. So omega L sin theta should just balance V1, so that the resultant of these two becomes in this direction. So from this concept, by component concept, what do we get? Omega L sin theta is equal to V1, same as we obtained by method 1, and resultant of these two is in this direction, but this has no component in this direction. Component of omega L in this direction should be omega L cos theta, that should be V2, omega L cos theta. Now if we divide these two, we get the same answer. If we divide omega L goes away, sin by cos becomes how much? Tan theta. V1 by V2 becomes how much? Tan theta. Same answer which we obtained in method 1 also. Actually, here we can also use the parallelogram law of vector addition. Okay. Now I grab this one, fine. Now we can also use the parallelogram law also. See, velocity of P2 is V2, vectors of these two. This is 90 degrees, this is theta. So P2 can be written as root under, V2 can be written as root under omega L whole square plus V1 square plus 2 V1 omega L into cos of 90 plus theta. Alright, so this becomes how much? V1 square plus omega L ka whole square, cos 90 plus theta becomes minus sin theta, minus 2 V1 omega L into sin theta. This is V2. Now we also know that the resultant of these two is in this direction. So in vertical component, resultant of these two should cancel out, as we did here also. So here also we will do the same thing. So V1 is just equal to omega L sin theta. Now what we do? We replace this V1 here. Alright. This all of it, okay? So we have to find the relation between V1 and V2. So we replace omega L, remove it, this, okay? So omega L becomes V1 by sin theta. Now substitute omega L here. Alright. So V2 becomes root under V1 square plus V1 square cosec square theta. 1 by sin theta is cosec theta. Minus 2 V1 square. Omega L becomes omega L sin theta simply becomes V1. Omega L sin theta becomes 2 V1 square. So this becomes V1 square cosec square theta minus V1 square. V1 common, root under cosec square theta minus 1. This is only cot theta. Cot theta is equal to V2. So V1 by V2 becomes 1 by cot theta. That is how much? Tan theta is the required answer. Alright. So V1 by V2 is tan theta. That is therefore the required answer. Fine. Now I have this one here. Now this was by SRC between P1 and P2 and selecting P1 to be the selected point. Now what we do, sub case B we solve method 2, sub case B of method 2. SRC between P1 and P2 and we take P2 to be the selected point. SRC between P1 and P2 and taking P2 to be the selected point. And then we have to find the relation between V1 and V2. Okay. So again I draw the diagram here. This is x-axis, this is y-axis, this is the origin, this is the rod length L, this is P1, this is P2, this is theta angle, velocity of P1 is V1, velocity of P2 is rightward V2. Now we apply SRC between P1 and P2 and take P2 to be the selected point. Now P1 becomes the other point, OP arrow becomes P1. So first what I I draw the line joining SP and OP, that is just the rod. So this is the line, this is the SP, P2. This is OP, P1. Now what I do, first action what I have to do, I give the velocity of SP to OP, fine. I give the velocity of SP to OP. SP is what? Velocity of SP is V2. So this I give velocity of V2 rightward. Okay, fine. Now I write down the sentence. Sense of omega of rod is omega anti-clockwise. So OP P1, OP and P1. P1 moves in anti-clockwise circle with P2 as center and radius L. Now if P2 is the center and P1 is to move in anti-clockwise circle with P2 as center, omega L should be in this direction, right angle to this. Then only it will be right angle, omega L. Okay, fine. And this angle you know is theta. Alright, fine. Now I have the first column. So velocity of P1 is the vector sum of these two. But we know velocity of P1 is how much? V1 in downward direction. So resultant of these two is just V1 in downward direction. Okay. So component of these two in horizontal direction should cancel. So this is theta, this is 90 minus theta, this angle will also be theta. So in this direction, component of these two should cancel out. So V2 should just be equal to omega L cos theta. Alright. Now again we can, two methods we have. Either we use that component form as we did in previous just now, or we use the parallelogram law of vector addition. Both of them we can use. In this direction, components cancel, so omega L cos theta should be equal to V2. In downward direction, component of these two should be V1 in downward direction. So omega L, this has no component in downward direction, only this has component in downward direction, omega L sin theta. So omega L sin theta is just V1. If we divide these two, V1 by V2, if we divide these two, V1 by V2 becomes sin by cos tan theta. So V1 by V2 becomes tan theta, same answer as you obtained. Or alternatively, we can also apply the parallelogram law. Resultant of these two is V1 in downward direction. So V1 we can write in like this: omega L whole square plus V2 square plus 2V2 omega L. Angle becomes how much? This is theta, so this angle becomes pi minus theta. You can see it. V2 is here, omega L here. This is theta, so this becomes equal how much? This becomes pi minus theta. So cos of pi minus theta. Is it alright? Fine. Now, from this equation, from this component concept, component of these two in horizontal should cancel. From this equation, we see that omega L cos theta is V2. So from this, we see that omega L is equal to V2 by cos theta. That is how it goes. So we substitute here. V2 square by cos square theta, V2 square, cos pi minus theta becomes minus cos theta, 2 V2 omega L cos theta. So this becomes V2 square, 1 by cos square theta becomes how much? Sec square theta, V2 square. Omega L cos theta becomes V2, so this becomes V2 minus 2 V2 square. That is same as V2 square sec square theta minus V2 square. That is simply V2 times root under sec square theta minus 1. This is simply tan theta. Write off this one. So this becomes how much? V1 becomes V2. Root sec square theta minus 1 is simply tan theta. So V1 by V2 becomes how much? Tan theta is therefore the required answer. Fine. Alright. So this I discussed the question from method 2. Method 2 I discussed. Fine. Now there is also method 3, but that we have not discussed the theory till yet. Method 3 is by using the concept of instantaneous center of rotation, which will be discussed in subsequent coming videos. Okay. So this I will discuss this part in that section. Okay. By using the concept of instantaneous center of rotation, that is IC concept. IC meaning instantaneous center of rotation. By using IC concept. By using what? IC concept. IC meaning instantaneous center of rotation. That we will discuss in the coming videos. Okay. To be discussed in the coming videos. In the coming videos, to discuss in the coming videos, successive coming videos. So I'll just mention it here. Okay, fine. This all grab it. Okay, fine. I'll discuss one more question in this 10th session on rigid body kinematics. One more I'll deal. Question is this: a rigid rod P1 P2, a rigid rod P1 P2 of length L slides down a fixed vertical wall as shown. This is the vertical wall, this is the horizontal ground. This is the vertical wall, this right angle. This is a rod P1 P2 of length L. This angle is theta. Velocity of P1 is given to be v in downward direction. Velocity of P2 is not given, it is rightward direction moving, but we don't know its speed. Angular velocity of rod is omega at the given instant. Okay. This v is with respect to ground. This omega is the angular velocity of rod with respect to ground. WRT meaning with respect to. I'll drop this one. So, question is, find omega at the given instant in terms of V, L and theta. Terms of V, L and what? Theta. Find omega in terms of V, L and theta. Okay. So this also you can solve by various methods. I'll solve by two different methods. Okay. Method 1. Method 1 is by SRC method. By SRC. So what we do, we apply SRC between P1 and P2. Again, we can select P1 or we can select P2, either one of them. I select P1 itself. So SRC between P1 and P2, and taking selected point as P1. Okay, we can take P2 also, there is no problem, but I take it in terms of P1. Okay, so OP becomes P2. Now I draw the line joining SP and OP, that is just the rod itself. This is P1, this is P2. Now I give the velocity of SP to OP. Velocity of SP is V downward direction. So I give V to downward direction. Okay. Now I write down the sentence. I say the sentence, rotation term. The sense of rotation is anti-clockwise. P2 moves in anti-clockwise circle, whose center is at P1 radius L. For P2 to move in anti-clockwise circle with P1 as center and radius L, velocity of P2 should be omega L in this direction. Okay. Now velocity of P2 is in rightward direction. So the component of these two is in this direction. In vertical direction, the components must cancel each other. Now see, this is theta. This is 90. This is 90 minus theta. This becomes theta by geometry. Component of these two in vertical direction should cancel. So downward component V should just cancel omega L sin theta. Omega L sin theta. Alright. From this we get omega is equal to V by L sin theta. This is therefore the required answer. Okay. This was the method 1. Omega becomes how much? V by L sin theta. Alright. Fine. I love this one. This was method 1, okay. So method 2, see, method is also another good method. This method is also good. See what we do, we use the concept C like this. This is P1, okay. This is P2, okay. This is V, downward direction, okay. This is theta. Alright, fine. Now this is L. Okay, velocity of P2 is in this direction, say V2, say with respect to ground. Okay, fine. Now see, distance between P and P2 is fixed, L, rigid body. Now we know from basic theory of line elements, in the first and second video of relative velocity, you go there. There we discussed rigidity constraint. If distance between two moving points is constant, then component of velocities of these 2 points along line joining them must always be equal. Now see, distance between P1 and P2 is constant L. So component of velocities of P1 and P2 along this line joining them should always be equal. So now this is V, is the component of this along this line is V cos theta. And this is theta, this is 90, this becomes 90 minus theta by geometry. If you extend this, this also becomes 90 degree minus theta. The component of P2 along this line becomes V2 cos 90 minus theta. Cos 90 minus theta. So V cos theta is equal to V2 sin theta. So V2 becomes V cos by sin becomes simply cot theta. Okay. Now we have to find omega. We can find omega with that concept, as we discussed in the second video of rigid body kinematics. Omega is equal to relative normal speed by separation. Omega is equal to relative normal speed by separation. Relative normal speed by what? Separation. Alright. I'll drop this one. So, relative normal speed by separation. So, consider this rod, see, P1. Velocity of P1 is V in rightward direction. P2 is V cot theta in rightward direction. This angle is theta, this angle is 90 minus theta. So, what is the normal speed of P1? This is V sin theta. Normal speed of P1 is in this direction, how much? V sin theta. And what is the normal speed of P2? V cot theta sin 90 minus theta. That is this component of this in this direction. V cot theta sin 90 minus theta. Okay. So V cot theta sin 90 minus theta is simply what? Cos theta. So normal velocities of P and P2 are in opposite direction. So relative normal speed becomes the sum of these two by the theory of relative velocity. So omega becomes V sin theta plus V cot theta into cos theta by L. Alright. So this becomes V sin theta, cot theta becomes cos theta by sin theta. Cos square theta by sin square theta by L. So sin theta is multiply here. V sin square theta plus V cos square theta by L sin theta. V common, sin square theta plus cos square theta becomes 1 by trigonometry. V by L sin theta. Same answer as we obtained previously also. Okay. So method 2 also same answer has been obtained. Omega equal to V by L sin theta. This is therefore the required answer. Fine. So omega becomes how much? V by L sin theta. That is omega. Alright. So this I have it here. The third method I'll discuss. So method 3 is what? Method 3 is by using the coordinate method. By method of coordinates, as we discussed in the previous question on this video. By method of coordinates. I'll draw the diagram here. This is the rod, this is P1, this is P2, this is V, velocity of P is V, P1 is V in downward direction. We take this to be the origin, this to be x-axis, this to be y-axis, this is the length L. Now P1 is moving on negative y direction, downward direction. Coordinates of P1 at any instant is P1 L cos theta. Okay. So y coordinate of P1 is y1, that is equal to how much? L cos theta. Alright. Now v is the speed of point P1, that is mod of dy 1 by dt. Alright, this becomes mod of d by dt of y1. y1 becomes how much? L cos theta. So this becomes, L comes outside. This we apply chain rule. D by d theta of cos theta into d theta by dt. This becomes L times mod of d by d theta of cos theta becomes minus sin theta. And d theta by dt is nothing but omega. So modulus of minus omega sin theta is simply omega sin theta. So this becomes omega L sin theta. So V is equal to omega L sin theta. So omega becomes V by L sin theta. It is therefore the required answer. And method 3 also. Alright. And there is one more method, method 4, to be using the concept of IC, instantaneous center of rotation, that we will discuss in the coming videos. Okay, that it cannot be discussed now because that theory has not even been discussed. So method 4, I just mentioned it here. Method 4 is by using the method of IC concept, that we will discuss subsequently in the coming videos. By using the IC concept to be discussed in the coming videos. Discussed in the coming videos. To be discussed in the coming videos. Fine. Alright. So this will close it here. Okay. So this was the 10th session of rigid body kinematics. Coming few sessions will again be based on this SRC concept. Okay. This is the lengthiest portion of this rigid body kinematics chapter. Fine. A very important chapter. Fine. So I close it here. Fine.